Howdy ho, neighborinos. We're coming to you with the Solar Power System Installation Series 9 clip from my solder station. This is, I've set the battery charge controller up here, or one of them. We're getting ready to mount this, and I wanted you to get a close look at it. I don't know if you're going to be able to see that. Anyway, what I really wanted you to see was what the inside of this looks like. This is going to be where your batteries connect to. That is like the power output. And this is going to be your power input from your solar panels. That is essentially going to come, let me set this up here, from your combiner box right here. You can see that. Your combiner box, which kind of groups together your series chains of solar panels, will come into here. We'll have about 54 volts and change coming into here during a very bright day. And then we'll have 48 volts or whatever the charge voltage is determined to be by the microprocessor in here coming out of the battery. This will go to another circuit breaker before it gets to the batteries. This will come from a circuit breaker before it comes from the individual 20 and 30 amp breakers coming from the PV units. If you can see down in here, there's a little fuse right there. That, I believe, either that one or one just like it, is our ground fault fuse. And what I mean by that is the documentation for the Xantrex charge controller states that your negative DC on this is connected to ground through that fuse, and that you are not to bond your negative DC bus to ground through any other means unless certain circumstances apply, which we're not going to go to that in this case. But essentially, if you are to rely on this fuse for ground fault protection, if there is a ground fault that exceeds the trip rating of that fuse, the fuse will blow and protect equipment and people from being hurt by that ground fault situation. If you ground your negative battery terminals or DC negative bus somewhere else, essentially what you're doing is providing an alternate route for ground fault current around that fuse, and also defeating the battery charger's ability to detect that ground fault as originally designed. There may be circumstances whereby your negative DC bus does not need to be grounded, or else you have an alternative means of monitoring and protecting ground fault situations, in which case you will remove that fuse. And there are some pin header jumper configuration jumpers, said that wrong, but they're pin headers that have little slide-on jumpers, and depending on where you slide that jumper on, this thing gets configured to know whether it should be utilizing that path to monitor ground fault current or some other path. As I mentioned earlier, we're going to have more than one battery charger in this, and each one has one of these, and as I just mentioned, you can only have one path, so only one of your battery chargers will have ground fault detection and protection enabled. So on our other charger, we'll remove the ground fault fuse, assuming this is it. I'll have to look into the literature just a little bit more to confirm that. I suspect it may actually be somewhere else. But and then we'll disable that jumper setting on the other charger and leave this one in place. The default configuration for these chargers is to be your ground fault protection system. So that's just how they come. And if you can see over to the side here, down in here, we have our ZAN bus termination plug, and this is for if this is the end of the line, that's kind of like a terminating resistor. And this only goes on the two end devices. So for example, let's say you have 4 devices on this communications bus. It will go from device 1 to device 2 to device 3 to device 4. Devices 1 and 4 would have this plug on the end connector. Devices 2 and 3 would simply just have a cable into each one going back and forth between devices to either side of them. So here in a minute, hopefully we'll be showing you what this thing looks like installed on the wall.